Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about the sliding window protocol. So, like the stop and wait protocol, sliding window protocol is also a method to implement the flow control mechanism. Yes, in our previous lecture, we have learned algorithm for the flow control, which is a stop and wait protocol. So, in this algorithm, also we are doing same thing. But it has eliminated the drawback of the stop and wait protocol, where the restricted amounts of data can be transmitted in one direction at a time. So what happened in the stop and wait protocol? We can send only one packet at a time after the acknowledgement received of that packet. Then after only we can send the new data packet, which is with that packet contains only a single packet. So that is the disadvantages of stop and wait protocol. So to remove that drawback, the new algorithm is introduced, which is a sliding window protocol. So by using this algorithm, we can send multiple packet at the same time. So the performance of sliding window protocol has improved by sending multiple frames bidirectionally at the same time. Here important is bidirectionally. In previous we have seen three algorithms that are the unidirectional. We can only send the data, we can't receive the data. Yes, so sliding window protocol is a bidirectional. We can send as well as receive the data at the same time. In this scheme, the sender sends sequentially numbers frame to the recipients in order to keep track of the frames, and if the header size is n bit, the sequence can range from 0 to 2 raised to n minus 1. So here also it maintains the sequence of packet at the receiving side by introducing the sequence number. It writes the sequence numbers on the packet. So by seeing that sequence number, we can reassemble that packets at the receiver side. So if header size is 3, then the sequence range can be from 0 to 2 raised to n minus 1. So it becomes 0 to 2 raised to 3 minus 1. So 2 raised to 3 is equals to 8 minus 1. So it becomes 0 to 7. So here the sequence range of the sequence number is become 0 to 7. So this is how the sequence number is assigned to the packets. Now how sliding window protocol is work on the sender side. So at the beginning of the transmission, the sender's window contains n minus 1 frame. Yes, whole message is contained via the sender side. Suppose it contains the message hello. So at the receiver side, whole hello message is there in the memory. If it sends to the receiver, then after he can remove that message from his or her PC. So as the frames are sent by source, the left boundary of the window moves inwards, shrinks the size of the window. This means if window size is W, if 4 frames are sent by source after the last acknowledgement, then the number of frames left in the window is W minus 4. Yes, because suppose there are W frames and it sends only 4 frames from that, but it still does not receive any acknowledgement. So the message contained, the frame left is W minus 4. When the receiver sends acknowledgement, the source window expands to allow in numbers of new frames equal to the numbers of frames acknowledged by the acknowledgement. Suppose the sender has 7 data frames, and from that he sent 4, so the remaining is 3. Yes, and if receiver acknowledged the 2 data frames, then the at the center side, the size to allow the new frames is become the 3 is already there. So now 2 is acknowledged. So the 5 frames is open for new frames. So this is how the sliding window protocol is used. So for example, let the window size is 7 and if frames 0 through 3 has been sent and no acknowledgement has been received at the sender side, so the sender's window contains 3 frames, which is a 4, 5, 6, because sender already sent the frames 0, 1, 2 and 3 to the receiver. So the remaining frames are 4, 5 and 6. Now if an acknowledged number is 3 is received by the source, it means 3 frames 0, 1, 2 have been received by receiver and undamaged. So the sender's window will now expand to include the next 3 frames in the buffer. Yes, this is something like that. The received acknowledgement number can be increased in the sender's frame. So at this point the sender's window will now expand the 6 frames. Yes, we already know the remaining frames are 4, 5, 6, and now it allows 3 more frames to include. So after 6 it is a 7, 0 and 1. So these are the next frame that needs to be included. So this is how the frame is included. Let's understand between this diagram. So at the receiver side, suppose there are complete 0 to 6 so this is the sliding window on the sender side. So now this arrow indicates that the wall moves to the right when frame is received in this direction. Suppose sender sends 3 frames, so this frame is slide by the 3. So now the new frame is drawn here. So this is how in this figure it shows that the 1, 2, 3 and 4, this 4 frame is received by the receiver. So it moves 3 frames, and now the next window size is 4, 5, 6, 7, 0 and 1. So this is how sliding window is work on sender side. Next is sliding window on the receiver side. So at the beginning of transmission, the receiver's window contains n minus spaces for frame, but not the frames. Yes, it just contains memory, but because it does not receive any message. As the message is received by the sender, it occupied that frames. So as the new frame comes in, the size of the window shrinks because it fill it by the frame, so that window size is shrinks. So therefore the receiver window represent not the numbers of frames received, but the numbers of frames that they still be received without the acknowledgement but be sent. So given the window size is W, if 3 frames were received without the acknowledgement being written, the numbers of space in the window is W minus 3. So this it received 3 frames, so the 3 spaces, 3 memories is removed from the window. So that is why the new size has become W minus 3. As soon as the acknowledgement is sent, window expand to include the number of frames equal to the numbers of frame acknowledgement. So as soon as acknowledgement is done at the receiver side, suppose receiver acknowledged the 2 frames, so 2 memories are free. So now the window size is W. After receiving 3 frames, it becomes W minus 3. Now after acknowledging the 2 frames, the now window size is become W minus 3 plus 2, it becomes W minus 1. So this is how the window size is shrinks and increase. So for example, let the size of receiver's window is 7, shown in this diagram. The size of receiver is 7. It means the window contains spaces for 7 frames. So these are the 0, 1, 2, 3, 4, 5, 6, 7. So these are the space for the 7 new frames. With the arrival of the first frame, the receiver's window shrinks and moving to the boundary from space 0 to 1. Now suppose it receives 1 frame, so this 0 position is occupied. Yes, so now this frame is moved here. Now the size is become 1, 2, 3, 4, 5, 6. Yes, after it also received 2 more frames, then this and this, this 3 size is occupied, and now frame is become now the window size becomes now the window size is become more smaller. But after acknowledging the 2 more frames, suppose it acknowledges the first 2 frames. Okay, now this first 2 frames is acknowledged, so our window pointer is at here, yes, and 2 more frame is acknowledged, so this pointer is moved 2 in this direction. So now our window size is become 1 2 3 4 5 6. Also the third frame is also acknowledged, then it moves 1 in this direction, and now our window size is become 7. So this is how the sliding window protocol is worked at the receiving end. So this is the same example that I have explained. So with the arrival of first frame, the receiving window shrinks, moving to the boundary from space 0 to 1. Now window has shrinks by 1. So receiver may accept 6 more frames before it is required to send acknowledgement. If frame 0 to 3 have arrived, but the dock been acknowledged, so the window will contain 3 free spaces. So as a receiver sends acknowledgement, the window of the receiver expands to include as many as new placeholders as newly acknowledged frames. The window expands to include a numbers of new frame spaces equal to the number of most recently acknowledgement frames minus the numbers of previously acknowledged frame. For example, if the window size is 7 and if prior acknowledgement was for frame 2 and the current acknowledgement is for frame 5, then the window expand by 3. 5 minus 2, as I said, it becomes 3. So this is how it works. Therefore the sliding window for sender shrinks from left when frame of data is sending, and the sliding window of sender expands to right when the acknowledgements are received. Same, the sliding window of the receiver shrinks from left when frames data are received, and the sliding window of the receiver expand to the right when acknowledgement is signed. So this is all opposite to each other. So this is how the sliding window protocol is used. As we understand this protocol, we can understand that it manage the flow control, it manage the multiple packets at a time. So this is a very important and useful algorithm rather than the stop and wait or the simplest protocol. So it has more advantages than both of them. So that's it about the sliding window protocol. Thank you so much for listening. Have a great day.